Today's lesson is going to start with relating fractions and division, which is the lesson on page 3 in book 7.2. 1/2 is the same thing as 1 divided into 2 parts. So what you're going to see is this fraction bar is basically code for the division symbol. Question 1 is simply going to give you a picture with a fraction. I've just given you the fraction 1/4, and you have to rewrite it as a division sentence. So the numerator is the same thing as our dividend, so it goes at the beginning. So it's going to say 1 divided by 4. So it always goes in the order numerator, which is our dividend, and denominator is our divisor, so it always goes second. Question number 2 asks us to explain why certain situations are the way they are. So they might say, explain why 24 divided by 2 is 3 times 8 divided by 2. And so if we look at it, 24 divided by 2, and we have 8 divided by 2, we're going to pretend that we're kind of moving up. I know this looks backwards a little bit, but 8 times 3 is 24. So let's see if our answer is also 3 times. So 8 divided by 2 is 4. 24 divided by 2 is 12. Well, yes, if we look, they're both 3 times. But we're starting with 3 times the number. So because your first number, your dividend, is 3 times greater, your answer will also be 3 times greater. They're also going to frame this as questions like, explain why 3 divided by 8 is the same thing as 3 times 1/8. And if we look at this mathematically, when we are multiplying, we multiply our whole number by the numerator, so that equals 3, and there's an invisible 1 denominator here, so that is over 8. And we know that we can rewrite this as 3 divided by 8. Okay? Question number 3 asks you to use the fact that A over B is the same as A divided by B to write the fraction as a decimal. We're going to keep dividing until the remainder is 0. The first step is to rewrite this as a division statement. So we just go in the same order. So 1 over 5 is the same thing as 1 divided by 5. Now we need to do some long division. So this is going to feel wrong, but it is the right way to do it. Our first number is what goes inside the long division sign, and our second number goes on the outside. We will need to use decimals. So 5 goes into 1 0 times. 0 times 5 is 0. We have 1 left over. Now we can add a 0 here and bring it down because we don't have a remainder of 0. 5 goes into 10 2 times. 2 times 5 is 10. Take away equals 0. Now that our remainder is 0, I don't need to put any more zeros over here. I'm finished. So this tells me that 1/5 equals 0.2. Question 4a asks you to change the fraction to a decimal using long division and then keep dividing until the remainder is 0. So if we look at this first one here, 8 goes into 1 0 times. So 1 minus 0 is 1. Then we bring down the 0. Remember to place the decimal in line with the decimal in the long fraction symbol, long division symbol. 8 goes into 10 once. So 1 times 8 is 8. 10 minus 8 is 2. Bring down the 0. 8 goes into 20 2 times. That gives us 16. Take away equals 4. Bring down the 0. 8 goes into 45 times, which gives us 40. And now we have a remainder of 0, so I can stop. If it wasn't, I would have to keep going. So this is part A. Now we're going to do the same process, but with 2 8s. So 8 goes into 2 0 times. 0 times 8 is 0. Take away equals 2. Now, as I bring the next number down, I'm going to include the decimal as well. 8 goes into 20 2 times. which gives us 16. Take away equals 4. Bring down the 0. 8 goes into 40 5 times, which gives us 40. Take away equals 0. So you notice I didn't need to include this last 0. I didn't need it. Part B asks you to find what the pattern is in the decimals equivalent in Part A. We're just going to see if there's a pattern between the first two. You'll have to confirm that by finding the third one. So, what is the pattern between 0.125 and 0.25? Well, if we look at this, you might notice that we can include a 0 there. It's the same number. And 125, when you double it, becomes 250. So, in theory, it should go up by 0.125 each time. Our first step is to convert each fraction to a decimal fraction. So, in order to do this, we need to figure out which power of 10 we can get 400 to become. So, we have to look at what's bigger than 40. So, after 40, we'd go to 100. Can we get from 40 to 100? No, because we go 40, 80, 120. So then we can look at 1,000. Well, if we think of 4 going into 100, we can kind of pretend that the two zeros aren't there. It goes in 25 times. So if we multiply by 25, that will give us our equivalent fraction. So 3 times 25 is 75. And then we need to write our decimal. So the next step asks us to change the fraction to a decimal. Now to do this, we look at how many zeros are after the decimal, and there are 3 zeros, so that means there's 3 places. Then we start filling in our numerator from the right-hand side. So we'd go 5, 7, and now there's a space here, which means we need a placeholder, so it would be 0.075. The third and final step they give us is to check your answer using a calculator. So in your calculator, you're going to put this as a division statement like this. So if we put 3 divided by 40, we would get 0.075, which confirms that our original answer is correct. The next part of our lesson is on repeating decimals, and we'll cover pages 4 and 5. A repeating decimal is a decimal with a digit or group of digits that repeats forever. So for example, 4.121212121212 would be a repeating decimal if the 1s and 2s kept going. And what we would do is put a bar over the numbers that repeat. A terminating decimal is a decimal that does not go on forever. It actually has an endpoint. For example, 5.68, it stops there, it would be terminating. Or even 0.444, although the 4 is repeating, it doesn't keep repeating after the third 4, so it would be a terminating decimal. There are some decimals that don't repeat or terminate, such as pi. The digits of pi go on forever, but there is no pattern of how they repeat. It's just a random sequence that constantly changes. Question 1 will ask you to write each decimal to 8 decimal places. So if we have 0.3, the 3 is going to keep repeating. So you'll just fill all 8 spaces with the number 3. There are also some examples where only some of the digits repeat. So if you look at this one, you might notice it's only the 2 and 6 that have the bar over it. Everything that comes before it will write as normal, and it's only the digits with the par that repeat. So we'll keep repeating 2, 6, 2, 6 until we run out of digits. I'm only going to give you a couple examples from number 2. There are more numbers, but they ask you to circle the repeating decimals. So we can look and go, okay, 1, 2, 3, 4, 1, 2, 3. Well, it's starting to repeat, but it doesn't have the 4 there. So the whole thing isn't repeating. It's just going 1, 2, 3, 4, 1, 2, 3, 1, 2. So the whole thing doesn't repeat. So we would not circle this one. 0.77, the 7s repeat, but there's no dot dot dot, so that implies that it's actually ending after the hundredths place. However, if you look at this one, the 2 repeats and we have the 3 dots, which means that the 2's keep going on forever. So this is the number that we would circle. When you're looking in your book, there will be 2 more examples that you have to decide whether they are repeating or not. Question 3 asks you to write the repeating decimal using bar notation. So if we have 0 point and then it's the 5 that keeps repeating, we only write it once, but we put a bar above just the 5, only the number that repeats. Now remember, if we're looking at B, we'd have 2 point, it's the 3, 4 that keeps repeating. So we need to put the bar notation above both of those numbers. There will be no circumstance when the bar can go over the whole numbers that come before the decimal. So whatever's there we keep putting, and it's only after the decimal that we include bar notation. Question 4 asks us to find the decimal value of each fraction to 3 decimal places. This is why we have 3 zeros after the decimal, because we're just going to 3 decimal places. Now we'll do our long division. So 3 goes into 1, 0 times 3 is 0, take away equals 1. We'll bring the decimal up and bring down the 0. 3 goes into 10 3 times, which gives us 9. And when you take it away, it gives you 1 left over. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Take away equals 1. Bring down the 0. 3 goes into 10 3 times. 3 times 3 is 9. Take equals 1. As you see, this pattern can keep going forever. So we're going to stop after the 3 places. The second step asks you to write the fraction as a repeating decimal. So 1.3 is about 0.3 repeating, or they might ask you to say about 0.333. Eventually we'll look at bar notation, but if you're starting with this, that's fine. Question 5 asks you to use the long division to calculate the decimal equivalent of the fraction to 6 decimal places and then to write the decimal using bar notation. So on the inside of our long division is our numerator and the outside is our denominator. Now, because they asked me to go to 6 decimal places, I'm going to put 6 zeros after the decimal. And now I start doing long division. So 6 goes into 1 0 times, 0 take away is 1. I'm going to put my decimal, bring down the 0. So 6 goes into 10 once, which is 6. Take away equals 4. Bring down the 0. It goes into 40 6 times, which gives me 36. Take equals 4. Bring down the 0. Goes in 6 times. That's 36, which equals 4. We're starting to see a pattern here. Make that 40. Goes in 6 times is 36. That gives us 4. Bring down the 0. Goes in 6 times is 36, which is 4. Bring down the 0. Goes in 6 times, which gives us 36. Take away equals 4. To write this in bar notation, we're going to go 0.1 does not change. It's just the 6 that keeps repeating. So the bar will only go over the 6. Question 6 asks you to match the fraction with their decimal equivalents using a calculator. I've only given you A because that's what I'm going to solve for, but I gave you all of the decimal options in your book so we can see which one matches. Now, if we were to use a calculator, we would see that 1 divided by 3 is 0. An infinite number of 3's, so the 3's repeat. So this is A, so you just write the letter on the line. You'll do the same thing for all of the other fractions, just use a calculator. Question 7 asks you to round the repeating decimals to the nearest 10th, 100th, and 1000th. So for our first question, as we are rounding to the nearest 10th, we're going to look at the 10th place, so this would be the 2, and the next digit tells us whether we're rounding up or down. So an 8 tells us we're rounding up, so to the nearest 10th, this would be 0.3. To round to the nearest 100th, I need to look at the 100th place, And then the next digit, 5, tells me I'm rounding up. So this would become 0.29. Finally, to round to the thousandths place, we underline the thousandths place, and the next digit tells us if we're rounding up. Well, 7 says we're rounding up to 6, so this would be 0.286. And you'll do the same thing for 5/13. Question 8 asks us to compare the decimals. So the easiest way to do this is to write them one above the other. So if we have 0.349, our 0.3 with the 49 repeating could go 4949, and you could even go one more set of 49s. Now, for each of these digits, there would be a matching 0 in the first number because the zeros are just wearing like invisibility cloaks. If we were to look at these numbers, the larger number would be the bottom one because there are more numbers after it. The zeros make it a smaller number. So the repeating decimal will actually be larger. Question 9 asks you to write each group of numbers in order from least to greatest. So I could once again stack these numbers up on above each other. So we'd have 0.4, 0.4222, and that could keep going. 0.4242, that could keep going, and 0.42. So if I add zeros to get them to all match up, then I can look at the first place where they're different. So all of these numbers have a 4 in the tenths column. So there's no difference. Now, there's 2's in 3 of them, and only one with a 0. So that means this is the smallest number. So we would start with 0.4. Then we could look at the numbers that are left. Well, 0 is our next smallest number. So 0.42 would be our next smallest. Then, if we looked at the 2 and the 4, 2 would be the next one. So 0.42 with just the 2 repeating. And finally, we have 0.4242. So both the 4 and the 2 are repeating. Question 10a asks you to use long division to write the fractions as repeating decimals and copy your answers below. So they give you 1 out of 9, 2 out of 9, 3 out of 9, and 4 out of 9. We're only going to do the first 2. So 1 divided by 9, we'll put our decimal here, so 9 goes into 1 0 times, so that equals 1. And then 9 goes into 10 once, which gives us 9. When we subtract it, that leaves us with 1. Bring down another 0, it goes in once. That's 9 equals 1. Now, we can see that this pattern is going to keep going, so we can just stop here. We know that this is 0.1 repeating. Now we're going to do the same thing with 2. How many times does 9 go into 2? Well, it can't go into 2 at all. So that's 0, and we have 2 left over. Bring down a 0, it goes into 22 times, which gives us 18, and that leaves us with 2. Can add a 0 and bring it down, goes in 2 times, that's 18, which leaves us with 2. The same thing's going to happen again. So now that it's continuing to repeat each time, we can just go, this is 0.2, and use our fraction bar to say that the 2 is repeating. The last question, part B, asks us to use the pattern you found in part A to find some other fractions. Now I've only included 3 here. What you may have noticed is that when it's a 1 over 9, it's 0.1 repeating. When it was 2 over 9, it's 0.2 repeating. Now if you do long division, this could confirm this for you, but we might guess that this is 0.5 repeating, 0.6 repeating. Now, you might automatically go, oh, is this like 0.9 repeating? But if you look at this, 9 out of 9 is actually like the same as 1. So don't worry about getting too tripped up about that, right? You have one whole.